Hello, I want to get you up to speed with the latest concepts to do with ChatGPT. Now, a lot has changed over the past year and some terminology didn't exist just a year ago. So ChatGPT is something called an LLM, a large language model. These LLMs essentially are just predicting the next word. So your phone does this. Every time you're typing something on your keyboard, you may see the sort of these words pop up at the top where it's trying to predict the rest of your word or even the next word. In essence, that is what ChatGPT is. It's much more powerful, but in essence, that is what it is. And you may have heard a lot of people basically saying that AGI or superintelligence is just a few years away. So now, how are we going from this glorified autocomplete to superhuman level intelligence? I'm hoping by the end of this video, you have an idea of how that might be possible. So now going back onto this autocomplete, let's say you're talking to ChatGPT now. Anything you type in goes to ChatGPT, but it's not just the text you type in. There's actually quite a bit of text sent beyond just the immediate text box. So in this example, there's a bit of text saying you are a helpful chatbot. Then there's then a bit of sort of completion where it says, oh, how may I help you? And then the user, meaning you're asking it a question. So now all of this text actually is being sent over to ChatGPT or any other LLM, large language model really. But ChatGPT is working on the full text, not just like the latest bit, and it doesn't really have memory. So, in 1 second it will process your text and then another second it will process someone else's. And there's no data being transferred, like it's not mixing up sort of your chat with someone else's just because it's just an autocomplete. Its response is based on the text it sees. And it's not remembering from one text to the other. So what happens is you send your request like this over to ChatGPT and it spits out one word, technically a token, but let's simplify it to a word for now. So it would say there, and then this word there would be put onto here, right? Saying bot there. And then all of this would be fed into ChatGPT and then it would say and then that would be put into this text and then it will be fed back. So this recursive loop goes on until the entire sentence or response completes. That's essentially how this system of next word prediction works. So imagine you going to your phone and you're just like by default tapping on the first suggested autocomplete. In a sense, that is what it's doing. It's a bit more complicated than that, but pretty much that is what it is. And because it's ended up so good, we've developed a lot of tools and stacked a lot of things on top of it. So one interesting thing is before ChatGPT, we had GPT-3. And when that came out, it wasn't obvious that the chatbot was the what's the word, killer app. But GPT-3 was marketed more as a few short learner where you could give it only a few examples of what you were after and it would produce and it would learn from that and to know what you wanted. For example, if you were looking for baby names, you would say, give me suggestions for baby names, and you would give it maybe a list of 3 and then it would come up with sort of a further 10. Or maybe like company names, you'd start with 3 and then it would just continue on with that list. And the first interface that OpenAI had was basically just this autocomplete text box where you just type in whatever paragraph, sentence, whatever, and then it would just autocomplete that. And even I myself made a little chatbot using that. I think the chatbot is just one of the most user-friendly interfaces to use an AI. Right, but either way, we've landed on ChatGPT. This is the killer app for autocomplete. And we've stacked up quite a few things on top of it. So now you see this bit of text and it goes into ChatGPT and it gives that response. Now this input text has been broken up into several parts. Let me show you. First, we call it, rather than just the input text, it's called the context window. Partly why it's called the context window is if you imagine like a single sheet of paper where all of your text is, if you give it too much text, it goes outside the context. So ChatGPT can only see what's within the context window. If you give it too large of a text, it would have no idea what you said at the start, only the right after you scroll all the way to the bottom. So ChatGPT only sees the context window. This is the text passed into ChatGPT, and the components of it are thus. I'll talk about embeddings in a bit, but what we've seen so far is a system prompt, chat history, and the user prompt. So in the example I've shown before, the system prompt was, "You are a helpful chatbot." So this is the identity of the chatbot and further instructions of how it should handle user requests. Now the chat history is just any relevant, just keeping a record just so that it knows what the users ask, just to keep everything on point and relevant and coherent. And of course the user prompt. I think these are fairly self-explanatory. I'm going to expand on the system prompt and the embeddings. With the embeddings, what the embeddings are really is just text. Don't let the word make it sound too complicated for you. It's just snippets of text. Other words you might hear in this context are RAG, meaning retrieval augmented generation, and also grounding. So one problem with ChatGPT and other LLMs is you train them and then you release them, right? But then after a year of having been released, it has a year's worth of data it hasn't seen, right? Meaning it doesn't know a lot about what's going around in the world. So ChatGPT itself, I think its training data, the last thing it's seen is like 1 or 1.5 years ago. I don't quite recall. But it doesn't really know the latest things that have happened, that have transpired over the past year or year and a half. So just say you're building, a football-based chatbot or AI. Perhaps you're going to just give it the full history of football, scores or any other commentary, perhaps. And then it would know that. It wouldn't have to rely on its training. So that's one example of why you might want to use this bit of embeddings. The retrieval augmented generation itself, one problem ends up being that you usually have far too much information than can be put into the context window. If you remember, I said the context window sort of scrolls all the way down to the text. So all the text has to be sort of fit into the context window. So what RAG does is it looks at all of the documents, anything that you want to potentially be an embedding. It looks through all of them and only adds in the relevant bit of text. And these snippets of text are called the embeddings. The RAG just goes and searches all of your documents, all of your emails, all of your databases, and extracts out the relevant text and puts them there. And grounding is just another word to say it's grounded in reality and it's not hallucinating. Yeah, and you can just think of this as the memory. It's like a short-term memory of what it knows. Anything it says that's not in that context window, it might be hallucinating, so you really want to make use of this if you can, but make it specific. So if you're in a company, you're probably going to put all of your company documents, right? ChatGPT wouldn't have that data. It's not on the public internet, so you probably want to give it access to your own data, so it can sort of explain the company reports, for example, or you ask it a question and it finds some random hidden away PDF and gets data from there. If you're making a personalized chatbot, perhaps you want to put your previous emails. And so if you say, "Oh, make this in my writing style," it's going to do that. It's going to know how you write, so you can write like you. And if you have a large database, you probably want to be able to pull things out so that ChatGPT can use that information. So all of that usually would go into the embeddings part, so that ChatGPT can make use of it. Right, so system prompt. I'm going to be sharing with you a little cheat sheet I've made for myself. So this is the identity of the chatbot, you might remember. I think a lot of people have trouble writing this. It's really easy to get up and started, but then as you're working with LLMs, the more you start working with them, you find edge cases where they don't work, where they just fall. And the system prompt is what you'll be tweaking. You might have heard of the term prompt engineering. And the reason that became a thing is because this system prompt is quite important in how the chatbot understands what you want it to do. Cool, so let's just go straight into it. At the start, you've got the instruction. I think a lot of people just do this naturally, saying, oh, you're a chatbot, you're a programmer, you're a critic, you're a scriptwriter. You might say you're writing a script for Hollywood. For programming, I might say you write the world's best sort of code, etc. Just keep in mind, I think the first two people do quite naturally. So keep to positive phrasing. Don't use negative sentences. So the chatbot was trained on human text. People don't really handle negative phrasing too well. So don't say do not do this, just say do this. Instructions over questions. I think naturally in the instruction itself, you're not going to use a question, but just keep this in mind. But the last one is quite important, where so if I give it a bit of code and I say, how can this code be improved? That's a bit too vague. So I might say, are there any syntax errors? Could some bit of code be optimized? And even that, maybe I want to break that down. So any instruction you give it, think about, is there a simpler version, or can I break it down step by step? Try to essentially do the work for the chatbot. Cool. Context is quite important. Just give additional information, really. So if it's a scriptwriter, you can say, oh, you're a scriptwriter for Hollywood. Perhaps just say, when I'm talking to ChatGPT, sometimes if I'm talking about medical stuff, it has a tendency to just not answer your question. For the context, I would just say, I'm a medical student. And I'm not, but that technically is context. But in short, when you have context, it just gives it more data to work with, and it makes its answer a lot more relevant to you. Examples. Few-shot prompting. Okay, cool. So earlier you might mention that when GPT-3, meaning the precursor to ChatGPT, came out, it was heralded as a really good few-shot prompter. Giving a few-shot prompting means you give it a few examples and it sort of knows what to do. So you still want to carry on doing that. Give it examples. So with the code example, in this case, I would give it a bit of code and I would say the problem was X, Y, and Z. Now, I think what I did was I would give it a bit of code and it would have to rewrite. I would give it code with bugs and it would have to rewrite the code to fix the bugs, and I gave it examples of bug fixes. The answer format. So this is useful when, just say, you're parsing PDFs or web pages or some data, and what you really want to do is take the result and feed it into another system, or just like parse it, So if you tell it to provide the answer in a specific format, it's going to do that. And then you can use the result quite easily, right? So if you're looking for the number ABC, you just search for number of ABC and you take that number, you're done. Otherwise, if you don't give the answer format, it could be anything. Cool. This last bit, the important part really is think step by step. Everyone tends to use this now just because if you just say you give ChatGPT a question. ChatGPT itself is quite smart now, but if you give it, just say what's 13 times 7, right? And it has to think up the answer on the spot. It might give you a wrong answer. But if you say, think step by step, what's 13 times 7? You might say, oh, 10 times 7 is 70, and then 3 times 7 is 21, 70 plus 21 is 91. Then it will get the answer 91. With this step by step or chain of thought reasoning, it's more likely to get the right answer. So you have two scenarios. On the one hand, it's forced to give the right answer immediately. And on the other one, it thinks through and then it gets to the right answer. Right? You can think of it as it has just more time to think, and when you give it more time to think, it's more likely to be the right answer. These other bits, take a deep breath, just ends up working a bit better. Not everyone really uses it, but I do. This do not provide a preamble. I tend to add it in just because I think with the latest updates to ChatGPT, it just ends up summarizing what you asked it. I just find that really annoying, so I just say do not provide a preamble. Last bit of tip is if you want to separate different sections, just use triple hashes or triple quotation marks. That's what I tend to do. So with the code, I would enclose the code within these type of triple quotation marks. Cool. Now it's just a bit of terminology. So ChatGPT itself, you can think of it as an agent or call it an agent. LLMs technically just predict text. An agent has, a bit more capability. An LLM embedded within, or given an LLM as a software that you can talk to, that would be an agent because it can do something. I think more technically, agents usually have more, like the capability of interacting more with the world, but it can be really simple at the same time. The term copilot has become very popular now. A copilot really is just an LLM agent within another software. Right now we've got Windows Copilot, Microsoft 365 Copilot, and then GitHub Copilot, and I think more on the way. It's just an LLM agent. It's just, think of it as ChatGPT, but it knows what's in your Word document, it knows what's in your code, it just has more context to work with. It's just another bit of terminology, don't get confused by it. Multi-agent systems. So imagine you give ChatGPT or a chatbot one system prompt and you build two others and you give them a different system prompt. So you make the first one maybe a programmer, and then another one tester, maybe a third one writes documents. And you have them work together to build a game for you. First of all, that's called a multi-agent system. We have multiple of these agents working together. And second of all, this is actually one project. There are I think many projects that have popped up, somewhat similar, but this is a nice diagram of it, where they have multiple chatbots working in different teams, and all passing code and back and forth to each other. And they can produce a decent quality game. I mean, it's really basic, and I think a lot of the times it's a bit buggy, but it does tend to produce better results than just asking ChatGPT produce a game for me. Just because you can imagine the first result, the first answer versus like a back and forth answer, it's not going to be as good. I think multi-agent systems are a current area of research, so I'll leave this at that. Cool. Now finally, linking up all the way to the start, how do we go from just a glorified autocomplete to having superhuman level intelligence? So ChatGPT and all of these other LLMs, initially they've been trained on just human text, and what they try to do is just be really good at predicting the next word, meaning that the best they can ever get if they just learn from human text is to mimic humans, right? If you're training to be good at predicting human text, then you're just going to be good at pretending to be a human. So that of course, would just limit its upper ceiling to just the best of well, the average of humans technically. Um, so if you want to become superhuman, you should do a bit more. So DeepMind some years ago created something called AlphaGo, and then they did something called AlphaZero. In this case, to become good at the game of Go, they had it initially train on human moves, and then after they finished training on human moves, it would play by itself. So initially, so really, what is going on with these AI companies now is they pretty much trained on all human text and videos and everything else already. And what they've started to do now is train or get the LLMs to play with itself, or rather talk to itself, or all of these agents talking to each other, to get better results. So I think there are many issues here. There's something called the objective function, which is how the AI knows it's going in the right direction. So the way you specify the objective function is really important in this case. So with the game of Go or chess or shogi, that's quite straightforward because you either win or lose, or you might have a certain amount of points when you play games. But just talking and out in the real world, how do you define what's successful and what's not? And I think what's happening initially is they're just giving it perhaps math equations or asking it to prove certain mathematical formulae, and I think that's a bit easier to understand whether the goal has been achieved or not. But yeah, the short answer is to achieve superhuman level AI, at least with the current technology. The best they can push it really is just have it talk to itself and provide it certain objective functions where it's clear, hopefully clear, whether it's met the goal or not. Cool, I hope you've enjoyed this video.